While D8 is not going to be on the test, of course, there's always going to be a couple of you nerds that actually want to find out how in the world did you do this, because I didn't figure this out. Well, what happens is we have a rocket that has two stages to it. And at first, of course, little flames are shooting out of this one. Let's make them red, it's prettier. So we have our fire. So the rocket is flying upward at a velocity of 132 meters per second when it detaches right here. Well, the lower stage we said is free falling. So if the lower stage is free falling, then we know its initial velocity was at 132 meters per second. But after that, our acceleration is going to be negative 9.81. And we said that it is going to fall for 15 seconds. So our time is going to be 15 seconds. It said the top part is going to continue upward at that constant speed. So if this is constant speed, then this is just plain v. And again, we still have that t of 15 seconds, which refers to this top part. So the top part, since it travels at a constant speed, we just have v equals d over t. So if we're looking for the d, the t comes up here. And we just find that we have our 15 times our 132, which gives us 1980 meters. And since that's positive, that's above the detach position. So wherever they detach, this thing after 15 seconds is that much higher. Well, how much higher or lower is this after that point? So again, we're going to use these three to find d. So if we're going to use this, we're going to use the d equals at squared over 2 plus vit. And in this case, the vi does not cancel out because we do have a vi here. So our a here, of course, is going to be negative 9.81 times our 15 squared divided by 2 plus our 132 times 15. So when we plug this correctly into our calculator, we find that we get a total of 880 meters. And again, since this is positive, it's still on top. So how far apart are they was what I asked, was how far apart are they? If this one is this much above the detached position, this one is this much above the detached position, then of course all I have to do is subtract them. So here I'm just going to take 1980 and I'm going to subtract 880, and what do you know? That's going to turn into 1100 meters apart. Now the second part of the question asks how fast is the lower stage at that time, or what is the velocity of the lower stage at that time. So now instead of looking for d, we are going to look for vf. So now we say what equation has vf and vi and ant in it. And of course that is our original acceleration equation solved for vf. So my vi is going to be 132 plus my negative 9.81 times the 15. And when we do this, we find the velocity is negative 15 meters per second. So if it's negative, that means this piece went all the way up and is starting to fall down again. So it's somewhere on its downward journey when it hit that 880 meters above the detached position. So it had gone a little bit higher than that originally. Since we have a negative velocity, again, it was headed on the downward part. Now, if we know our velocity changes 9.81 meters per second every second it falls, this is about 1.5 of these. So that means I must have been falling for about 1.5 seconds past this peak point. So I must have hit that peak point more or less at about, 12.5 or 13.5 seconds. So at about 13.5 seconds, I hit stop, and then I was falling back down for 1.5 seconds, and that's when I would have hit this. So that kind of puts the placement of where everything is.